Section 2.5, 2.6. Example 2. There are 20 hockey players on a team, 2 of whom are goalies. How many sets of 5 skaters and 1 goalie can be on the ice at the same time? So the order in which the players are on the ice does not matter. This is a combination question. We want 1 goalie on the ice. There are 2 goalies to choose from. So 2 choose 1. And so we multiply, and we need 5 skaters on the ice. We are told there are 20 hockey players in total, but the 2 goalies are included in those 20 players. So to find the number of hockey players that are not goalies, 20 minus 2, there are 18 players that we can choose from for the 5 skaters to go on the ice. So 18 choose 5. 2 choose 1. There are 2 ways. 18 choose 5. There are 8,568. The total number of ways to pick 5 skaters and 1 goalie to be on the ice at the same time